Hello, Algebra 1 students, and welcome to our fourth lesson here in Chapter 4, which is on graphing functions. And this is actually going to be the last lesson that we're going to do for this chapter, because as we progress through after this chapter, we're going to continue talking about graphing and understanding a lot of different components that happen with graphing. So today I'm going to give you kind of some of the basics of graphing functions. And I thought this little drawing would be fun, kind of showing you different equations and different types of graphs they give. He is just illustrating them with his arms then instead of making it an actual graph. So our objectives are I can graph functions given a limited domain, and I can graph functions given a domain for all real numbers. So we're going to be talking about graphing these functions given that I have a certain domain for them. So we actually don't have a key idea right away. We are going to go right ahead into a problem so that you can see how this is done. So they say graph the function for the given domain. So we need to graph, and they give me the domain. Remember, my domain is the same as my x values. So they give me the equation negative x plus 2y equals 6, and here is the domain they want me to use. So one of the ways to graph functions, and what we're going to talk mostly about in this video, is making a table. So we have x and we would have y values. So you can make what is called a t-table by having your x and your y. That is something we've talked about doing tables prior. So what I would do is I take the x values here, so negative 4, negative 2, 0, and 2. What I'd have to do is plug in or substitute in that value for x and then solve for what y is. But right now my equation is not written so that it's equal to y. It says negative x plus 2y equals 6. Well, if we go back to one of the first chapters we talked about rearranging equations like this. So I actually want to solve this equation for y first. So I'm going to write this out as negative x plus 2y equals 6. I want to get the y by itself on this side of the equation. So I would actually get rid of this minus x first by adding it over. It says subtracting x, so I need to add it. These cancel. Now I have 2y equals 6 plus x. And then I need to get rid of this 2 that's being multiplied by y, so I divide it by 2. And I'm actually going to leave it as 6 plus x divided by 2. You could simplify this 6 divided by 2 to 3, but I think it might be easier to compute and plug in for my table here. So if I plugged in a negative 4, I would think, okay, 6 plus negative 4. 6 plus negative 4 is a lot like saying 6 minus 4, which is 2. I divide it by 2, and I get 1. So I'm plugging this in, so what I did is I took the y, I did 6 plus a negative 4, because I plugged in that negative 4 for x, and then I just solved out for y. So I'm going to do the same thing for negative 2. 6 plus a negative 2 would be 4. 4 divided by 2 would be 2. If I plugged in a 0, 6 plus 0 is 6. 6 divided by 2 is 3. What if I had a positive 2 here? 6 plus a positive 2 would be 8. 8 divided by 2 is 4. And so remember then that once I have this table, it makes those coordinate points. I'd have negative 4, 1, negative 2, 2. I'd have 0, 3, and I'd have 2, 4. So when I go over here, and I think I'm going to actually get a different color. Let's go for blue. I'm going to plot the point negative 4, 1. So I'm going to go over to negative 4 and up 1. I'm going to plot negative 2, 2, negative 2, 2. I'm going to plot 0, 3, 0, 3. And I'm going to plot 2, 4, 2, and 4. And then typically when we are graphing functions, what we do is we connect all these dots together, and it's not going to be pretty on my end. What I suggest if you're doing paper and pencil is to get it straight. And then they go past these dots to show that it continues, and then I draw in that arrow at the end. So again, try and get it as straight as you can digitally. It's pretty hard. So let's take a look at another one. So we are going to graph this function for the given domains. So again, we're going to graph the function for the given domain. This time we have something written in function notation. So it says f of x equals, and then I have the absolute value of x. And then they give me my domain, which again, remember, means my x values. So if I'm going to start setting up a table for x and for y, I could have x, but remember, y is also the same thing as f of x. So I'm going to put f of x this time. They tell me I want to use -4, -1, 0, 1, and 2. So then what I'm going to do is I'm just going to plug in this value for x into my equation here. And what it means is all I'm going to do is take the absolute value. Remember, anything that goes in that's negative turns out positive. Anything positive turns out positive. So basically, I'm just going to have the positive version of this x. So the positive version of -4 is 4. Positive version of -1 is 1. 0 doesn't do anything, so it just stays 0. 1 stays 1, and 2 stays 2. So when I go over here and graph those then, I plot -4, +4. I'm going to plot -2, -1, +1. I'm going to plot 0, 0. I'm going to plot 1, 1. And I'm going to plot 2, 2. What happens when I make a graph like this is it goes all the way down here and then it decides to change and go back up this way. And again, I want to extend it past that, and I'm going to draw in some arrows. So what happens when you have an absolute value is you end up with kind of like a V graph. So I think that's kind of how that little guy looked on the first page. Where is it? Yeah, right here. So this is where he's showing that one. So let's take a look at a little bit of a key idea here. So it says if the domain of a function is all real numbers, any number can be used as an input value. This process will produce an infinite number of ordered pairs that satisfies the function. Therefore, arrowheads are drawn on both ends of a smooth line or curve to represent the infinite number of ordered pairs. If a domain is not given, assume that the domain is all real numbers. So just like I was showing on these, extending these out, that's because I could figure out what is 6, but I didn't put that in right now. So we want to show that it's going to continue on because I could have infinitely many different solutions that would, infinitely many domains as well as infinitely many ranges that go with those. So that's what they're talking about on those curves or the ends grabbing in those arrows. Then something they also give is this lovely step-by-step, which I like because this is the steps I've been using in this video and are going to be important when you graph. So I would highly suggest writing these steps down. So it says graphing functions using domain of all real numbers. Step 1, use the function to generate ordered pairs by choosing several values for x. So in these first few, they gave me the domain, which are my values for x. In the first step that they don't give me that, I can pick any value for x that I want. I tend to pick something easy so that I can get it on the graph. But if you wanted to put 1 million, you could. I don't suggest that. I'll tell you what I suggest here as we continue on. Step 2 then is to plot enough points to see a pattern for the graph. So once you have those points then, I highly suggest plotting at least 2 to 3 points on your graph at minimum. If you want to plot all of them, you can. But at minimum, so that way you can see what direction this graph is going. And then step 3, connect the points with a line or a smooth curve. So let's take a look at another type of problem here. And all their direction is graph the function. So we are going to follow those steps. So step 1 was to figure out what values for x we would like to use. So I would suggest taking something that's negative taking 0 and then taking something that's positive. So maybe let's decide that we want to use the values of x as -2, 0, and +2. That gives me at least 3 values, which I said 2 to 3 are going to be the biggest help on setting up that graph. So what we're going to do is we chose those x values, and then we're going to generate these ordered pairs by setting up that table. So again, I'm going to set up a table where I've got x and y. And so my equation this time is already solved for y, which is awesome. So I have 2x plus 1 equals y. So I'm going to have -2 as my x, I'm going to have 0 as my x, and 2 as my x. Remember, these are considered my domains. I'm going to plug in -2 into x, so that means I'd have 2 times -2, which is a -4, plus 1, which would give me a -3 for y. So again, I'm just plugging these in, substituting them in, and solving for y. I'm doing it mentally math. If you want to write it out, you're more than welcome to. 0, well, 2 times 0 is 0. 0 plus 1 is 1. All right, what if I put in a +2? 2 times +2 is 4, plus 1 is 5. So now I have the point -2, -3. So I'm going to pull out that one. I have the point 0, 1, and I have the point 2, 5. All right, once I have that, then we said we connect the dots. Let me just double check on our steps here. I think I'm rushing through. Plot enough points to make the pattern. So that was step 2, was here. And then step 3, connect the points of the line. So that's what I'm doing right here. +3. And then we need to continue out with the line and draw those arrows. So it's okay that I go past those points, but as long as I'm trying to keep it in that straight line. And there is my graph for this function. We got about 2 more problems. We'll see if we can get to all of them here. So the next one, we need to graph this function of y equals x squared. So again, step 1, we decide on what values for x we want. I'm going to do the same thing. I'm just going to do -2, 0, and 2. That way I can get a good gist on kind of how this graph is going, and if I want to add more, I can. So I'm going to set up my table, x and y. I'm going to plug in my x values. Then my y. So if I plugged in -2 squared, in this case, a -2 times -2 makes a +4. So it's like saying it's this version of the squaring. So a negative times a negative makes a positive. Well, 0 squared times 0 squared is just 0. Nothing I can do there. But +2 times +2 is also a 4. So I'm going to plot -2, 4. This is step 2 now. And then I'm going to plot 0, 0. And I'm going to plot 2, 4. And so this one, actually, I think maybe one more point might be helpful. What if we did like 3? Or what if I did 1? I think 1. Maybe that would be a little easier. Let's put in 1, because I can't tell quite what my graph's doing. 1 squared times 1, or 1 squared is 1. So I put 1, 1. Oh, what if I did -1 as well? Well, -1 times -1 is a +1. So what happens in this one is it's not like the absolute value ones that were straight out as a V. This one actually kind of curves in a little bit. So as you notice, I ended up adding a few other x values just so that I could graph this out a little bit better. And I'm trying to line this up as best as I can. So drawing in that curve and adding that. So step 2 plus step 3. The last one, I should be able to get to this pretty quickly, so listen carefully. It gives me the graph. It says use the graph of the function to find the values of f of x when x equals 6. So sometimes they might ask you to analyze these graphs. They gave me the equation, but really they just want to know what is f of x when x equals 6. So if I looked at my table and I went over to 6 and I went up, well, I noticed that f of x then is at 4. And you can always check that by plugging it back into this equation and seeing, you're plugging in the 6 in and seeing, do you get a 4